Okay. We started talking about doing operations on fractions, right? And we got through multiplying fractions, but we didn't get to dividing fractions. So that's what we're going to start with today. So the first thing I want you guys to remind yourselves of the meaning of quotative division. So in particular, if you have an equation like a divided by equals c, think about the a, how could you think about the b, and how should you think about the result, the c, right? Under the quotative view of division. Okay? So take a second to think about that. Feel free to super quiet over here. What's going on?
Okay, so A divided by B, are we talking like, okay, where A represents the dividend?
Okay, well, so that's like the name for it, but that's not really how we should, like, that's not going to tell us much about how to think about it, right?
Okay.
So if the variables are throwing you off, pretend that you've got 6 divided by 3 equals 2.
Okay.
Under the quotative view, how should you be thinking about the 6? How should you be thinking about the 3? And how should you be thinking about the 2?
Okay.
Using quotative division. You guys remember the two different views of division?
Yeah, quotative and partitive.
Uh-huh. Do you remember you're still waking up too. Do you remember the like casual names for quotative and partitive? It's like user-friendly names instead of quotative and partitive, because people can never remember those. No?
I'm trying to remember without looking.
Okay. That's good, because it's a cumulative final exam. Gotta know it.
I don't know, like, I guess, like, I always look at this one,
Mm-hmm.
but, like,
So, and for both of those diagrams, what's the division being demonstrated? 6 divided by 3. Yeah. Right? And so under the quotative view, you're basically looking for how many copies of 3 are in 6. There's 2 copies, 3 and 6. And then under the partitive view, you're saying, if I were to equally share 6 things into 3 groups, how many objects are there per group? So we often call partitive view the equal sharing view. And we'll call the quotative view like the measurement view, or repeated subtraction. Okay. Okay. you guys doing?
How
Oh, you've jumped ahead. Okay, we'll get there. Can we talk about this one first?
the quotative division?
Mm-hmm.
She said, like, from the notes that it was, like, how many B's are in A.
Yes.
So we said, like, how many 1/2s are in 3/4.
Beautiful. And so if you want to jump ahead, then you could already start to think about how you would draw a picture and be able to see that there are, like, 3/2 copies of...
I don't get how to draw pictures for the fractions.
Yeah, it's a little trickier. So you, like, this might give you an idea, right? Like,
Yeah.
this is a picture that...
Like, I see the first one,
Mm-hmm.
but that's all.
Okay. So I'll give you a hint so that you can mull over while the rest of the class is catching up to you. So I said of something to sort of make an emphasis here, right? So depending, like, anytime you conceptualize a fraction, you have to first think, what is the whole, right? What is the unit? And so in order to see 3/5, think of this entire rectangle as my whole
Okay.
that I've divided into 5 equally sized parts, and 3 of which I care about, right?
Mm-hmm.
But to see thirds of something,
Make it different.
we need a different whole. And so I could, for instance, look at just whole. Now, if that's my whole, then I've divided it into 3 equally sized pieces. And how many of those pieces do I have?
Oh. Okay.
Make sense?
Yeah.
Okay.
Thank you.
Yeah. We dug through our notes and figured out what quotative division was again. So we're already reviewing for the final. It is cumulative and not that far away. Oh my gosh, we're almost there. Okay, so quick comments. If you were struggling with the variables in the equation, what could you do? Put some numbers in there, right? So if you don't like A, B, and C, then you could throw in 10, 5, and 2, right? Or 6, 3, and 2, 6, 2, and 3, or however you want to do it, right? So that you can try to make sense of the statement, and then go back and generalize to using the variables. So in particular, what did you decide the quotative view of division says? How do we interpret A divided by B equals C under the quotative view? So we could think of A represents total number of objects. Okay? B represents the number of objects per group. Okay? And that means C has to represent what? Number of groups. Okay? So this way of thinking works really well. This language for describing this way of thinking works really well in the discrete case, meaning when I have whole number values, right? So it's easy to say, like, a total number of objects if I have 6 objects or 10 objects. It becomes a little trickier when you start to say 5/2 objects, right? And likewise, well, I don't know, maybe you're comfortable with that. Are you comfortable with that? Saying you have 5/2 objects? 2.5 objects? I mean, hopefully they're not humans, but, you know, like, right? For most things, you could cut them up and, okay, cool. So another way that you might have thought about this is how many, or rather than stating it as so the left-hand side, you could think of as answering how many copies of B are in A, and so C is the answer, right? C is the number of copies of in, right? So that would be another way to think about quotative division for this particular equation in your head. Just so that we're all on the same page, what was the partitive view? How do you think? Yeah, equal sharing, right? So if I have A number of objects divided into B groups equally, then I get C number of objects per group. Okay? So those were the two views of division. Because my brain works this way, I'm going to emphasize this view for the purposes of division of fractions. Okay? I've been working all morning on trying to make sense of the partitive view with fractions in a non-contrived way, and I just haven't been able to come up with something super satisfactory. I'm still working on it. Dang it, now I just admitted to the entire world that I haven't figured it out yet, because this is going on YouTube. Okay. I was talking to my colleague about it, and he's like, it's obvious. And I'm like, no, it's not. Okay, so here we go. So if we're thinking about the quotative view of division, by the way, do you see what just happened? Can we have a meta moment? Can we have a meta moment? Meta? I just admitted that I didn't know something. I am your teacher. That's okay. Right? You don't have to know everything. Right? But what you should be willing to do is try to figure it out. So after class, I'm going to keep talking to my colleague until it makes sense in my brain. Because, okay, in my defense, what he's thinking isn't right either. Because he's thinking about dividing by a whole number and then multiplying by a whole number, which is equivalent to dividing by a fraction. But it's not the same way of thinking. And so anyways, I got to work on it. Okay, but I'm going to work on it, and hopefully by Thursday I'll have it figured out, and maybe even sooner than that. So if I can figure it out by noon today, then I'm going to post something online for you guys to start thinking about for class at the start of class on Thursday, okay? But that was my meta moment. It's okay not to know everything. What's important is that as a teacher, you model interest and willingness to learn, right? Learning is a process. It's supposed to be hard. If it wasn't hard, you wouldn't be learning, right? If it was easy, that means you're not actually growing, right? Learning is supposed to be hard. Okay, so anyways, okay. Fourths divided by 1/2, then how should I think about what this says? What's a way that I could, rather than just saying the numbers, 3/4 divided by 1/2, what question could I answer with this expression? Yeah. How many, can you be more specific? How many copies of what? How many copies of, yeah, you were good. Of 1/2 are in 3/4. That's the question that we answer with this division. So now let's see, right? So if I wanted to visualize what's happening, I could say, all right, well, here's my whole, and I want to know what 3/4 looks like, right? Because I want to know how many copies of 1/2 are in the 3/4. So I should start with the 3/4. Agreed? Okay, so let's create fourths. And we're going to consider 3/4. Okay? And so now the question is, how many copies of 1/2 are in the red area? Okay? So if you think about it, we've got 1/2 happening here, yeah? So for sure, I have one whole copy of 1/2. Do you see that? So this is one copy of 1/2. And then when we come over here and we see this one little square shaded in, how much is this out of 1/2? It's half of 1/2, right? It's half of 1/2, which means altogether I have one copy of 1/2, half a copy of 1/2. So I have 1 1/2 copies of 1/2 in 3/4. You want to try it on your own? I gave you a new one. So I said, try this again, where we do 3/4. This one's harder, by the way. 3/4 divided by 2/3. Okay? So I want you to take maybe 3 minutes in your groups to try to tackle this. This is for you. So you've drawn your 3/4, and what do you want to do next? What are those dotted marks representing?
2/3 and 3/4.
So this 2/3 is still 2/3 of the whole. I want to know how many copies of 2/3 of that one unit fit into the 3/4 that I've already shaded.
So how many 2/3 are in 2/3?
Right. But the 2/3 is 2/3 of the whole thing. Like, we're not changing the unit on the 2/3. So it's not 2/3 of 3/4. That would be multiplication. It's it's how many copies of the 2/3 of.
So the whole would be 3/4.
No, we're not changing the whole. The whole is staying the one. The entire.
I don't get how to make 2/3. Just to redraw it, like we did.
Do that immediate, but at some point you're going to want to combine it all into one.
How do you cut it in half? Would we cut it right there and make it 2/3?
This one's hard. So let's do. Show me this one first, okay? So if you take 3/4 divided by 1/4, what question are we asking here? How many copies of 1/4 are in 3/4? Can you answer that without even drawing the picture? Hopefully. So you should be anticipating the answer to be 3, okay? But let's see why, right? So if I take my whole and I look at how big 3/4 is, that's still this much, right? Okay. Now what I want to do is say, if I think about 1/4 of the whole still, so this 1/4 is referring to the same one that this 3/4 is. Okay? So when I say 1/4, it's not 1/4 of 3/4, it's 1/4 of the one. So that's this big. Right? So this is 1 copy of 1/4. And then right here I have a second copy, another copy, this is 1 copy of 1/4. And then right here I have a third copy. So all together I have 3 copies of 1/4 in 3/4. Right? Okay, so what made this easy? The denominators were the same, which meant I was measuring parts using the same ruler, basically, right? I was using the fourths ruler for everything in this example. Whereas I was using the fourths ruler to create my 3/4, but I was using the halves ruler to talk about 1/2. And so when I use the half ruler on something that was already divided into fourths, right, I've got 1 full copy of the half. I only have half a copy of my half ruler. Do you see that? So I'm pretending for, what am I pretending? This is my ruler. Maybe white wasn't the best color choice. Right? But if this is my ruler, I have 1 full copy of my ruler, and then I have half a copy of my ruler. Where my ruler is whatever this number is out of the whole. So over here, I've got a quarter ruler, right? And I've got 1, 2, 3 copies of what I've shaded. Is this making sense so far? Okay. So then, I want to think if I can come up with an easier example than the one that I have on your worksheet. Let's do 1/3, no, let's do 2/3 divided by 1/6. So again, the question here is how many copies of 1/6 are in 2/3? What are you thinking about?
That's 2/3.
Perfect.
And then now I have to figure out how many.
And how big is a 6? how big it is in, say, relation to 1/3. Yeah, the size, exactly. In particular, if you cut this in half, you get a 1/6 there and a 1/6 there.
So it's just the 2/3.
No, it is right.
It is?
Yeah.
Oh,
Colors would be useful,
okay.
but no, that's right.
Okay.
You don't have enough boxes. You have 5 boxes. Yeah.
Sorry, I was doing it.
Oh no, don't apologize. Which one are you doing?
I did that
The-
one, but then I did that one because I figured out you have to.
Oh, but careful. Oh, you were so close. There's 12 in that hole, right? And remember, this is answering the question, how many 2/3 are in 3/4? Right. And so in particular, okay, I said enough. You think about it. Okay. How are we doing?
Can I see it? Or does it have to be in one box? In the picture? Like one diagram?
Can you explain your picture to me?
Like, so obviously so I can see what 2/3 is and 1/6 is, but I have to have them the same size.
Yeah, they should be the same size.
Yeah.
They don't look the same size, so that's bugging me a little bit.
Oh, sorry. And then, so when I split the 2/3,
Mhm.
this is my invisible line.
Okay,
So that's, I have 4 copies of 1/6.
beautiful.
Okay.
Yeah.
So that's okay that I have them
Yeah.
split up?
So you should like label some things though.
Oh, sorry. This is, and then this is 1/6, but they are the same size. Oh, this is the size.
So when you say 1/6, but you shade 4 of those, then I get confused. So when you say 1/6, you
Oh,
mean
well,
just
I
one
guess,
of those
yeah,
little
I'll
rectangles,
do
right? So
that.
draw like an arrow or something.
Like that.
Beautiful.
Cool.
Cool. Okay, so I got the impression walking around that this went a lot better. So okay, you take your whole and you divide it into thirds, and then you said, okay, measuring. Basically, I'm interested in measuring this whole using a ruler of size 1/6 of the whole. Right? So my ruler is this big. Measures out 1/6 of the whole, right? So this here is 1, right? But more importantly, it's 1/2 copy. No, said that wrong. I said that the wrong way. Delete the last 10 seconds of your life. Okay, so it's 1/6 of 1, which means I have 1 copy of 1/6 so far, right? But now I have a second copy. And, right, because if I use my ruler stick there, and then if I use my ruler stick again, and then use my ruler stick again, and use my ruler stick over here, right? I don't need to go that far, but if I did, that'll emphasize that you've got 1, 2, 3, 4, 5, 6 equally sized pieces. So that's how I know that I'm measuring in 6. But now when I see this, I can see, aha, I have 4 copies of 1/6 in 2/3. Aren't diagrams cool? Like once you actually have a way of thinking about division that's meaningful, then you can actually make sense of fraction division. Isn't this so much better than flip and multiply? No. Oh, you don't think so? No. Oh.
This is easy, flip and multiply.
But it doesn't mean anything. But what does it mean? Like, why? It's voodoo. It's magic, right? Like, oh, then I have failed. Shoot. I'm going to try not to cry. That actually makes me want to cry. That really means I have failed. Absolutely. Being able to do mathematics quickly is not the, like, being able, so, sorry, I said that wrong. Being able to perform computations quickly is not equivalent to being good at math or enjoying math even, right? Because doing 2 divided by 1/6 and saying that's the same as 2/3 times 6 and getting that answer, that's not mathematics. That's computations, right? Mathematics is all of this stuff. It's all of the underlying structure where we're able to make sense of things around us because of meaning. And we're able to capture that meaning using notation and quantities so that we can, like, better understand, like, okay, I'm going to have to keep working on you then. Yeah. Okay, I'm not going to cry right now, though. Okay, so we have that. So we have 3/4 divided by 2/3. And the thing that's challenging about this is that, so if you notice, right, these denominators aren't nice when you compare them to each other versus 4 and 2, 4 and 4, 3 and 6, right? Like, these share common factors, whereas 4 and 3 do not. Which means when we create our units and we highlight what 3/4 looks like, but then we want to say, I'm going to measure this amount using a ruler of size 2/3. Well, guess what? I can't use any of my pre-drawn lines here. Nothing will overlap, right? When you think about how big 2/3 is compared to 3/4, which one's bigger? Okay, so here's the question, right? Which is bigger? Is 3/4 or 2/3, which way does the inequality go? Okay, let's draw more pictures. Okay, so we're going to make equally sized units to compare. Okay, so notice I drew my boxes about the same size. And I'm going to divide this guy into 4 equally sized pieces. And I'm going to divide this guy into 2 equally sized pieces. And I'm going to shade in 3 of these, and I'm going to shade in 2 of those. Now, if I compare which one's bigger? 3/4 bigger. Okay? So you want that discount. All right? Okay. So 3/4 is bigger, which means, so I mean, I basically drew it there, but if I bust out my 2/3 ruler, right, on this bad boy, then it's going to land somewhere around here. Which means right off the bat, for instance, that I have 1 copy of 2/3, but then I have this little bit extra. So I do and then something, right, to figure out what the something is. So that's the tricky part, is figuring out how much that little bit is extra. But how could we do that? So I'll go ahead and I'll draw in, okay, so if I'm measuring in 2/3, that implies that I've been doing something with thirds. So we'll go ahead and draw in where 1/3 would be. So now I've got thirds and fourths on the table. How could we relate thirds and fourths to each other? via twelfths. Beautiful, right? So 1/4 is the same as 3/12, and 1/3 is the same as 4/12, right? So if I break this guy down all the way into twelfths, then I'm good to go. Okay. So in particular, this is a fourth, so there are 3/12 inside of that guy. This was 1/3, and so there was 1, 2, 3, 4 twelfths there. So we're good, right? And then I'll need 5, 6 twelfths, 7, 8, 9. Right? Okay. So in particular, okay, so here's where shit gets weird. Okay, so remember, this is my ruler. How many parts did I just break my ruler into? So this is covered up at the moment, right? So I've got 8 tick marks on my ruler. Should I back up? Yeah, no. This is important. So if you're confused, we'll start over. Okay? So we created our 3/4 in blue. And then this big red is my ruler. So my ruler, like literally my ruler, right? So I'm saying my ruler is this big. And it has 8 equal tick marks on it. 8 equally sized tick marks. And if I try to measure this last little chunk, I can notice that it's exactly the size of one of those tick marks. Is that a little bit better?
So you don't count the last piece?
No, we're getting there. We're not done yet. What I'm just trying to help you guys figure out is what fraction of a copy you have here. Right? So what I'm trying to figure out right now is what fraction of a copy of 2/3 do I have here? And so what we've discovered is, well, we've broken our one copy of 2/3 into 8 pieces, which means each of these is 1/8 a copy of 2/3. We have 9 of those copies. So you could either say you have 1 and 1/8, or you have 9/8. You see it?
So a
Yes.
question I would have is, you made it 8, but you said it's like you
Yeah.
said it's the whole, right? And then, well, over here you said you look at the whole.
Yeah, to figure out what the 2/3 was. So 2/3 of the whole. But then, once we figured out how big 2/3 is, now I'm making this my ruler. And in order to use this ruler effectively, I had to divide it up into 8 equally sized pieces. Right? So over here, the 1/2 was my ruler. And technically, we had to break that into pieces over here, right? Because we didn't have a whole half, we had half of a half. Right? So that's why I said half of a half. Right? So if I were to label this guy, this is 1/8 copy of 2/3.
Why wouldn't it be 1/12?
Because, oh, yeah, that's the question, right? So notice that I'm saying 1/8. I'm treating 2/3 as my whole when I'm talking about how big this is, right? Now, technically though, you are correct. This is 1/12 of 1. That's not relevant to the activity that we're doing, right? No. One way that people like to do this to make their lives gymnastics that just happened, right? So one thing that some people like to do is say, well, this is music. But if I think about the fact that 3/4 is equivalent to how many twelfths? 9/12. And 2/3 is equivalent to 8/12. Now I'm measuring them using the same stick anyways. So I'm really just asking how many copies of 8 are in 9? 9/8. Right? Because the denominators are the same. Right? So in other words, you could re-picture this, where now I'm going to focus on the fact that I've divided my 1 into 12ths. And so the blue part is 9 copies of those 12ths. And the, up to here is what I'm measuring in terms of. Yeah? Cool. Okay. Fractions are amazing. They're so freaking cool. So one of the things that's fun about these diagrams is that you can, I forgot. So that when I project on the screen, I did actually have a reason for not making slides. When I project on the screen, you can't see it in the video. Like the text doesn't appear. So these diagrams are flexible. It's all about how you look at them. So in particular, so right now what I want to do, I know that was hard, right? Okay, so dividing fractions is intense. But fractions are so cool. So I want to remind you that they're so cool. So we're going to look at one diagram in 6 different ways. One diagram, 6 different ways to interpret it, okay? So I think, right, when you look at the diagram on the page, how do you have to be looking in order to see 3/5 of something? So this is the diagram. Pretend those are equally sized, okay? And we have 3. Okay, so when you look at this picture, what process do you have to go through? Say it bigger, say it louder. This entire thing has to be your 1, yeah? Okay? Whole rectangle is the unit, right? And it's been divided equally into 5 pieces, 3 shaded, right? That's how you have to, that's like what your brain has to do in order to see 3/5 in this picture. Now let's play with it. What does your brain have to do in order to see 5/3 of something in this picture? impressive wait time, don't I? Anybody feel like they got it? Dan?
So see 5/3. The 3 shaded would be the original, and then we have 5 equal parts of 3, which includes the unshaded portion.
Okay, so you're saying you have to see the shaded part as your unit, right? Shaded part is the unit, and it's divided equally into 3 pieces, right? Right? The shaded part is divided equally into 3 chunks, of which there are 5. Right? 5/3. That's the meaning of 5/3. Yes? So, if you think about what 5/3 means, you take a whole and you cut it into 3 equally sized pieces. And then to have 5/3, you need to have 5 copies of those pieces. So we've got 1, 2, 3, 4, 5 copies of the thirds. You see it? Sweet. Okay. Let's keep going. If you wanted to see 6/10 in this picture, what would you need to do? So you take the same box, pretend that's the same size box, okay? And then what do I want to do with it? Divide them all in half. So you could either do that vertically or horizontally. I'm going to do horizontally because it's faster. Okay? Okay? So to see 6/10, cut whole rectangle in half, creating tenths. Okay? All right, now we're really going to get to business. So now we want to see this one, but it's doable. 2/3 of 3/5. So ignore the 6. Come back to this one. So using this diagram, how could you, quote, see 2/3 of 3/5? Bless you. Anybody feel like they can explain it? Okay. Where? Oh, okay. Wait, what do you want me to do? So you want me to take my whole that's already been divided into this. Okay, and then you want me to mark 2/3 on it? So that's somewhere over here. That's tricky. Do you have a different idea? Okay. So you started with the whole. So see rectangle as the unit. Equally sizes. Oh. 2/3 of what?
Of what the whole would look like.
Oh, you guys are really okay. Let me see. So challenging. I was going for something a little easier. Yeah, I mean, maybe I'll take this one over. Okay, so cut into 5 equally sized pieces, of which you shade 3 to see your 3/5, right? But 3/5 is cut into 3 equally sized pieces. Right? In particular, each of these pieces is the same size within this 3/5. Yeah? So I could think about one of these rectangles as 1/5 of 1 or 1/3 of 3/5. You see that? 2 ways to look at the same rectangle. So in particular, if a rectangle of this size is 1/3 of 3/5, then where could I see 2/3? Over here, right? 2/3 of 3/5 of whole. Well, we'll just leave it at 2/3 of 3/5. Okay. Feeling. So from thinking about this now and seeing that it's divided into. So that's why I said 1/3 of 3/5, because now I'm treating the 3/5 as my new whole in order to see of something. Okay, but 2 of those are the same as.
Okay.
Yeah?
Oh, I see.
So that's what made this a little tricky, is that the is outside of the whole. So you would have preferred, you could have just said, okay, well, I could look at these as 2/3. If that would be fine too. Actually, that might make more sense to most people, right? Okay. Cool? How are we doing? Okay. What about 5/3 of 3/5? Okay, so what I just wrote down, I'll recap. So in order to see 2/3 of 3/5, we had to imagine the entire big rectangle as our whole, cut into 5 equally sized pieces, and shade 3. So in other words, we redid the first part, right? We redid visualizing 3/5, okay? But then we treated the 3/5 as a new unit and said, that's divided into 3 equally sized pieces. So each of those pieces is 1/3 of my 3/5. So to get 2/3, I would need two of those little pieces, two of the little rectangles. So what would I need for 5/3? I would need 5 of the little rectangles, right? Do we have 5 of the little rectangles? We sure do, right? This entire thing could be seen as 5/3 of 3/5. What's the other way to think about this entire thing? 1, right? Or 1. Guess what proved? Multiplying a fraction by its reciprocal will give you 1. So here's my challenge to you. If you would like to, say, be extra prepared for this week's quiz, you would go home and do something like try to explain why 2/7 times equals 1. Or why 3/4 times 4/3 is 1. Or why 7/6 times 6/7 is 1, right? And you can do that. I know you can do it in the same way that we did here. Okay? How do we use this diagram? How do we use this diagram to see 1 divided by 3/5? So this is the new stuff, right? This is what we just did at the start of class. So how do I use this picture to see 1 divided by 3/5? How do we think about that division? How many copies of 3/5 are in 1? Beautiful, right? Okay. Well, how many copies of 3/5 do you see? For sure, there's 1 copy. Now, how do we describe this much in terms of this ruler stick? So remember, I'm using the 3/5 as my ruler stick, right? So the question now is, how many copies of this are here? 2/3. Yeah? So this is 1 copy of 3/5, and this is 2/3. So you get 1 and 2/3, or 5/3. Okay? Okay? So your favorite memorized algorithm holds, yeah? Divide is the same as flip and multiply, right? But now still want to cry. Okay, I'm not going to cry. Here we go. Okay. I have a whole bunch of, is that right? We're doing good. Okay. So I have a whole bunch of problems on here. Just to, again, like sort of like bring all the fraction stuff together, because we've done a lot with drawing diagrams in the very abstract, but we haven't done a ton with word problems. And so what I've got here is a collection of word problems involving fractions, but they're not scary anymore. Why are they not scary anymore? Oh, because we understand fractions and we have meanings for the operations. So when we read word problems now, we can make sense of them. Like, oh, they're just dividing things into equally sized pieces. That's division. Or, oh, like they're trying to figure out, like, if I have 2/3 of something, that's multiplication, right? Like, we know these things now. So word problems aren't scary anymore. Okay? So try to rely on the meanings that we've developed in order to interpret what computation will give you the right answer. And I strongly encourage you to think about whether or not there's a diagram that you might draw to help yourself. Okay? So take a couple of minutes. Maybe we'll divvy these up a little bit. So how about you guys do number 1, you guys will do number 2, you guys will do number 3, and everybody will do number 4. Okay? Question?
Is it correct? Like, I have to see them two different.
So explain to me what you're thinking.
Okay, so obviously I start with
3/5.
the 3/5.
Yep.
And then I shade it out.
Okay.
And then, like you said, now we're only looking at this part. So I take one more.
Okay.
And then it's I could see that it's the 5 pieces of 1/3.
No, so we want to do. Oh, wait. So what are you going to say?
Like, what I see is that there's 5 copies. That there could be 5 copies of one.
Yeah, okay, so when you see 5/3,
Yeah.
that means there's 5 copies of 1/3.
Yes,
But the
that's
question
exactly
is 1/3 of what?
Of the
Of
piece, yeah, of
exactly.
the 2/3. That's why it's only this part and not the whole.
Right. So, okay, so when you part, how many equally sized pieces were there?
3?
Yeah.
Yeah.
Which means each of these is already 1/3. You don't have.
Oh, so here I'm not supposed to do
No.
this part?
Because this shaded piece is already 1/3 of all of the shaded.
Oh.
Do you see that?
Mm-hmm.
Okay, because there's 3 of them. So each one must be 1/3 of that.
And then what about for this one?
Okay, hold on. Let's finish this one first.
Okay.
So if each of these is 1/3 of that, then I have 1, 2, 3, 4, 5 copies of the 1/3.
Mm-hmm.
Okay? And then up here, we had our 3/5 shaded. You shaded a little bit more than 3/5. I would unshade that. You shaded too much. Okay, so 3/5 is shaded, and guess what? 3/5 is already divided into 3 equally sized pieces. So I know how big 1/3 of 3/5 is. It's that big, like this whole thing. So then if I take 2 copies of that, then I get 2/3 of 3/5. I'd like to point out that what you wrote down does not actually match what's on the board. Yeah. So the 1/3 of 3/5 is just one of those boxes. And then 2 of those boxes will give you the 2/3.
I said 1/4.
Okay, so like what?
But
Like
the
is
reason
there
I
an
said
answer,
1/4
or are
is
you
because
just
there's
showing the
like
shaded?
3
Is that like the
1/12,
point of
which
this?
would reduce to
Oh, well, the answer here, 5/3 of 3/5 is 1, right? Because when you break down the 3/5 into thirds and then take 5 of those thirds, you get back the entire 1, right? And then here, sorry, you're right, I didn't give you an answer.
Okay, yeah,
So
that's
2/3 of 3/5 is what? So if I take my 3/5 and I consider 2/3 of that, that's the same as 2/5 of the whole.
Okay.
Yeah, but
You don't need those dividing marks.
that's because
So can I draw that?
1/12.
So if you take your whole, you say I have 1,
But this, the
and
3,
I have
this is 1/4
3/5
because
of that.
there's 3/12 and 3 over
Then
12.
each of these is 1/3
3 over 3,
of
you would get
the
1
3/5,
over 4, which is 1/4.
right?
And this is technically 1/4
So
of
then
the whole.
that's
So
1/3
if you had it
of
divided
3/5,
into fourths as well,
which means this
like, you
much
could see
is
it's a
2/3
little
of 3/5.
Because we're looking at this piece only. Okay.
But now if I zoom back out in relation to the entire whole, I could also see this much as 2/5 of 1.
Okay.
Thank you for pointing out. I didn't realize I didn't answer the question. Can I just had to point it out that we never actually you gave a complete answer to what this value should be. So 2/3 of 3/5, you can see it as these first two rectangles in the diagram. But if you were to actually compute the value of what 2/3 of 3/5 is, then you have to zoom back out to the whole, right? So then I would say, okay, so now I know that this much of my diagram is 2/3 of 3/5, but now what is that much in relation to my whole? Oh, well, that's 2/5. Okay, sorry. I realized we didn't actually answer that, and some of you might have been left hanging. Okay. Okay, keep going. Yeah, please do. Okay. Yeah, that's fine. I'm not convinced. Maybe here. I realized, William, you're so tall that when I stand right there, the camera was just aimed at your, it was just getting this. That's all it was getting. Okay. How you guys doing on yours? I don't know. Oh, what's your problem? So, You're making cupcakes,
Yeah.
and it requires 1 1/3 cups of sugar. It's 5
5.
cups of sugar total.
How many? 1/3 in 5.
Yeah, perfect.
So this is 1 copy.
Mm-hmm.
1/3. 1 copy and 1/3. 1 copy and 1/3. So overlaps.
You've got those 3 shaded guys, right?
Yeah.
So if you think of how many of those little pieces are in 1 1/3, how many of those little pieces are in 1 1/3? Like how many of these little shaded guys are in 1 1/3? So each of these little shaded guys is 1/4 of 1 1/3. Do you see that?
Yeah.
Katie, do you see that?
Yeah.
Okay. So that means you have 1, 2, 3/4 copies of 1 1/3.
Which is the same as
Well, yeah, but that's not what's relevant right now, right? Because the answer to this question is how many copies of 1 1/3 are there, right? So you have found 1, 2, 3, and 3/4 copies. You see that?
Oh, that's equal to 15 over 4.
Sure. I have no idea. I believe you. Yes. I can do that in my head. Yes. Okay. Cool.
We are confused on the number 3 of how to do 1/2 or how to do 1/4 of the half.
So tell me how you're thinking about the problem first.
So how I tried to explain it is that, okay, so he has 3. Okay, so he needs 3 and 1/2 because that's what the recipe needs, but he can make only 3 and 1/4. So it's 3 whole ones, like it's the same for both, so I guess those don't really matter. And then the last one, it was, so he needs 1/2. So like we drew 1/2, but he can only make 1/4. So then we separated by 4, and then like he can only make this, so he would need like the other half.
So be careful a little bit though, because so this 3/2 is referring to what? It's 3/2 of what?
I see. The flour.
The flour, right? 3/2 of a cup of flour. And this 3 1/4 is referring to what?
The recipes.
Recipes. So they're talking about different things, right? And so,
so he had 3 and 1/4 of the recipe?
So if in one recipe requires how much flour?
3.5 cups.
3.5 cups. 2 recipes requires how much flour?
7 cups.
7 cups. 3 recipes would require 10.5 cups. And then you need another 1/4 of a recipe. So what are you really looking for?
That 1/4 of the 3.5.
What is 1/4 of 3.5 cups?
Okay.
So what kind of problem is this actually? What did you just do? I just had him add repeatedly. Yeah. But also, like, the activity that Nathaniel just engaged in, right? I said, how many in one recipe? How many in 2 recipes? How many? And all he did was add how much each time? 3.5 each time, right? Repeated addition. Okay. The only thing that makes this a little tricky is the fact that there's a fraction in there. Okay. How you guys doing?
At first we thought that we could multiply.
Okay, yeah.
So we were like multiplying 3.5 cups by 3 1/4.
Yeah.
So we did 3 sets, so 3.5, 3.5, but then we moved this one 1/4. And only,
But then it came out to like 11 or 3, 6, 9, 10,
And 10 and 1/4. So that's not what we found.
Okay, so the 3.5 is representing a number of cups of flour, right?
In just one.
In
recipe.
one recipe. So you need this much flour for one recipe. You need that much for the second. You're going to need that much for the third. But then you'll need a quarter of this for the last little bit.
Oh, so not.
So it's not a quarter of a cup.
Well, yeah.
It's a quarter of
that
the recipe amount.
So just a quarter of what this is.
After you've already, I mean, technically you can do it all together through multiplication. But yes, multiplication is the operation, right?
Okay.
So if you finish the 2 that you've been assigned, what should you be doing? The other ones. Okay. Are we ready to talk, or where are we at?
They want to know how many batches.
Okay, so let's run through these discussion style. So we had two tables concentrate heavily on number 1, so let's all read number 1. We've got, at a bake sale, 1 pan of brownies was 1/3 full. Mr. Fuller bought 3/4 of what was left. What part of the pan of brownies did Mr. Fuller buy? So how could we attack this problem? You guys help us out. So we draw our pan of brownies, okay? We have red brownies. Okay. Then what? I feel like you skipped a step 2. So, how much of this what is he doing? Giving it away? Or no? Oh, he bought 3/4. So he bought 3/4 of this. So how do I figure out what 3/4 of this is? Divide this guy into fourths, right? And so he bought 3/4 of that. Okay. But the question is asking how much of the entire pan did he buy, right? Not just how much of what was there did he buy, right? So if I was really trying to test how much you're paying attention to your fractions, I could ask you a question on a quiz where I said, I gave you the exact same first 2 sentences and then said, what part of the brownies that were left did he buy? I already gave you that information. It's literally right there. It's 3/4, right? Okay. That's why paying attention to the unit is so important, right? The 3/4 has a different unit than the 1/3 and what the answer is asking for, right? Both the 1/3 and what the answer is going to be refer to the entire pan. So that means when we go back and look at the entire pan, we need everything to be in equally sized pieces. So we can extend our of these pieces into fourths, right? So that we end up with each of these guys is now 1/12 of the pan, right? So he bought how much? Mr. Fuller bought 3/12 or 1/4. Now, here's the thing. In order to see the 3/12 is equivalent to 1/4, you have to manipulate your thinking about this, right? Because where do you see fourths in the diagram? There are these horizontal slices, yeah? Do you see that? So there's 4 horizontal slices. So these are the fourths, whereas the vertical slices are the thirds, right? And so in order to see the 3/12 as 1/4, you actually have to basically imagine picking up this piece down here, and this piece, and Oh, no, sorry. Then not that piece. You have to imagine picking up this piece and moving them here and here. Right? To see the 1/4. Luckily, like, that's a thing that you could do, right? So you could imagine doing that. But without imagining doing that, it's not obvious that you have 1/4 of the pan. Do you see that? So in particular, again, if you were doing this on a quiz and you just wrote 1/4, I'd be, without like showing me anything or explaining anything, then I'm going to be like, no credit. Have no idea how you got there, why you did that. Okay? Yeah. Wait, what? Say that again? That's what I'm trying to explain to you right now. Like, if, to me, that is a perfect answer. If you say that without explanation, 0 points. No idea where that came from, right? Okay. Because again, right, the whole purpose of this class is not to make sure you get, I mean, it's important that you get the right answers, but it's more important that you be able to communicate and explain why things work the way they do. That's the point of this class. Okay. Otherwise, I'm just teaching you guys like 5th grade math, right? This is college class. There's got to be something more going on here. Okay, so Bronson made cupcakes for the sale, right? A recipe called for 1 1/3 cups of sugar, and he used all 5 cups of sugar that he had in his pantry. So how many recipes was he able to make? This is number 2, right? So this is a thing that happens, right? Like you're in your kitchen and you've got like your big old thing of sugar or whatever, and you're like, well, I don't want to have any of this left over in my house, so I need to use all of it. So let me scale my recipe and make a bunch of things, right? So, okay, so let's figure out how many recipes he could make with what he had in his pantry. Oh, by the way, let me take a step back for just a second. This diagram is an explanation for why of 1/3 is equal to 3/12. Right? This diagram explains this process. But ultimately, this was a multiplication problem. Okay? Over here, when you read the problem, what's going on? I've got 5 cups of sugar, and I need 1 1/3 cup for each recipe. This is a division problem. Right? I could think of each recipe as being my group, basically. But instead of saying recipe, I'm going to say how much sugar is in each recipe. So this boils down to saying 5 divided by 1 1/3. Okay? But again, if I want to be able to like really help somebody understand, first of all, why I could even write that expression on the board, because maybe they're not there yet. Maybe they still need a visual. Okay, so we can do that for them, right? So let's do it. So we've got, you guys had a nice diagram in the back. You just drew like 5 of these, right? So here's the 5 cups of sugar that are in my pantry. And I want to know how many recipes I can make using this amount of sugar if it takes 1 1/3 cups for each recipe. So each of these is this is 1 cup sugar, right? Each box is 1 cup of sugar. And so 1 1/3 cups, well, here's 1 1/3. So I've got, there's 1 recipe, right? And then, let's see, we'll just say another 1 1/3 here maybe. This might not be the best way, optimal way. So there's 2 recipes. Oh, and then 1 will come up like this. 1. There's 3 recipes. But now, check it out. I've got this like white space, right? So I've still got sugar to use. And my question is, how much of a recipe can I make with that amount of sugar? So that's the question. So I'll say it one more time. So the question is, how much of a recipe can I make using that amount of sugar? Well, notice one recipe requires how much of these little pieces of sugar? 4 pieces. How many blank spaces do I have? 3. So I have 3/4 of a recipe worth of sugar. Yeah? So I've got 1, 2, 3, and 3/4 recipes that I could make with that amount of sugar. Okay. We have another recipe problem. Are we ready to move to number 3? You guys going to help me with number 3? You guys? Yeah? So number 3. We've got a recipe that called for 3.5 cups of flour. But somebody, whoever he is, could only make 3 1/4 recipes. So I want to know how much flour he had. So when you think about this problem and what we know about the operations, what does this problem boil down to? This is a multiplication problem, right? I have 3 1/4 copies of 3.5 cups of flour. So this is what we're going to end up figuring out, right? But how are you going to help somebody to understand that this is what's happening? In other words, what picture could you draw to help somebody figure this out? That this is the thing they need to do. Because remember, I just taught you division of fractions. So shouldn't every problem be a dividing fractions problem? That's how math classes work, right? It's not a very useful way to learn math. So, okay. The tables I saw over here had some interesting pictures, right? So I saw one table that said, okay, so one recipe would take 1, 2, 3.5 cups. 2 would take 1, 2, 3.5 cups. Recipe 3 would take 1, 2, 3.5 cups. But then we've got this extra quarter of a recipe that's going to nag on us. So what do we need to do in order to figure out how much a quarter of a recipe is? Is it confusing because I didn't use a rectangle? So because I have 3 1/4 recipes that he made. Did you see that? So he made 3 1/4 recipes. So I have 1 copy. Sorry, maybe my numbering system was bad. See, this is why labels are important. So my labeling system didn't work for you. So let's come up with a better labeling system. So we've got maybe 1 copy of the recipe, another copy of the recipe, another copy of the recipe, and a quarter of the recipe is what we're going to draw to make a total of 3 1/4 copies of the recipe. Better? Yay for labels. Good. Thanks for holding me accountable. Okay, so now we need to figure out, though, how to represent a quarter of a recipe. Well, we could do something like, well, this would be the whole recipe, right? Well, I could take a quarter of each of these. So if I take a quarter here, a quarter here, a quarter here, and a quarter of that, then I have a quarter of a recipe, right? Okay, but how much is that? Well, what is this half circle divided up into? 1/8 of the whole circle, right? So it's divided into fourths, but it's fourths of the half. So if I were to do this big to a whole circle, I'd have 8 slices, right? So I have 1, 2, 3, 4, 5, 6, 7, 8. So let me come back over here. So this is 3 1/2 cup of flour or sugar or whatever it is. 3 1/2 cup. This is another 3 1/2 cup. But this is, what did we just say? 7/8 cups. So now if I want to know the total amount of flour, I just add these up. So it's whatever 10 1/2 plus 7/8 is. 11 3/8. Cup flour. Oh, yeah. How are we doing? It feels hard because you weren't taught this way. But I promise you, if you are willing to put in the energy to think in this way about fractions and to really get comfortable with them, you'll be able to teach it to children in a way where this is like, yeah, cool, got it, right? It only feels hard because it's new. But again, that means you're learning. It's the whole point of a college education. Yes? I can happily repeat the last part. So what we did was we took one whole recipe, and I originally divided each of the pieces of the recipe that I could identify into fourths. And so these guys were all like the same size, so the fourths looked the same size, right? But then over here, to divide this into fourths, I ended up with like a tinier piece, right? And so then what I wanted to do was figure out, okay, well, I want to combine all of these, but remember, in order to combine things, I need them to be of the same size. So that means I need to slice everything the way I slice this guy. So I went back and I cut more slices so that they're all now smaller bite-sized pieces, and I figured out that there were now 7 of those little pieces, and each piece was 1/8 of the whole. Victory. Okay? I assigned a lot of problems out of Chapter 7 very intentionally, right? This is challenging, and I'm asking you to think about it in a new way. So I wanted you to have as many opportunities to practice the new way of thinking as humanly possible, right? Because without repetition, right? This is not mindless repetition, though, right? This is like repetition where you're doing it over and over again until it becomes second nature. Just as second nature as flip and multiply, right? So by repeating this process of making meaning out of what you're doing with fractions, you will get better at it, and it will become more comfortable. So that's why your homework is a little bit longer than normal, okay? But I genuinely believe that it's worth the investment on your part to get comfy with the fractions, okay? All right, we're going to dive into integers full force on Thursday, and we'll take an in-class quiz on everything up through what we did today, okay?